What I really need is a microphone. Are my videos bad quality, like speaking wise? Yeah, I know, because if I'm talking over here, we're great. If I walk around the room, you can't hear. So what I did was, I used the A, the B, and the C. The quadratic formula. I simplified. One more step, I'm factoring out that 2, or you can separate the 2 terms, and I get negative 2 plus or minus radical 2. Okay, but the thing that a lot of students forget is what is on the left side. It's not x. Now you guys were like thinking, don't erase. You guys were thinking of this being, a lot of you even wrote down, oh, that's the same thing as kind of like x squared plus 4x plus 2. But it's not x squared, right? It's tangent x squared plus, or 4 tangent x. So this side over here isn't just x, it's tangent x. So now, I know at least one group used u substitution. If you're using u substitution, so you did u's instead of x's, then this would be like u equals u equals u equals. But at the end, you have to put tangent x back in. So what I have now is I have this quadratic formula simplified all the way to tangent x is equal to this. And there's 2 answers. One of them is positive, one of them is negative. So maybe I'll do that next. I'll say tangent x is equal to negative 2 plus radical 2, or tangent x is equal to negative 2 minus radical 2. Because there's 2. But how do you find x? Before you tell me how you find x, what is x? What are we trying to find? Like, what is x according to what we've been studying? What is x? It's an angle. And you can tell by the directions as it says solve for all angles. And it says between 0 to 2 pi. So we're finding angles. We're finding angles that tangent at that angle is equal to negative 2 plus radical 2. Or tangent at that angle is negative 2 minus radical 2. Take a moment, without saying anything, think about how you could possibly find the angle at negative 2 plus radical 2. Don't say anything. Think. My next question is this a special value that we've already had memorized? It is not a special value that we have memorized. Special values of tangent is like radical 3 over 3, or 1, or radical 3, or is that it? 0, so undefined. Those are the ones that we know. Not once do we have a negative 2 plus a radical 2 for tangent. This is not one that I know. And if it's not one that I know, how are we going to find the answer? You have to do inverse tangent. So right here, we're going to inverse tangent. That's the only way that you can cancel out. That's not us. That's the only way that you can cancel out tangent is by doing the inverse tangent. You have to do it to both sides of the equation. Remember we did that a long time ago. Remember? A long time ago? We did. We did inverse, and it looked different because it was a decimal. We did things like inverse tangent of negative 0.2390. Okay, it wasn't a radical, but this is a decimal if I type it in my calculator. So if you do not know the value, then you have to use your calculator. What mode, before you even start, what mode should our calculator be in? Yeah, because we look at the answer and it has to be between 0 and 2 pi. It's got to be in radian mode. And we're going to do inverse tangent. -2 plus radical 2. You could do minus first if you want, but it's going to be in a different order than me. Question.
Okay. You just look at
Yeah.
Are we not going to be like
No, because when you do an equation like this, you don't put the x's in here. You only put the coefficients, the numbers more.
So,
Okay, so now, this is not an answer.
Because it has to be positive.
Because your answers have to be between 0 and 2 pi. So what we did when we did this before is we drew a picture. We said, all right, if it's negative 0.5299, that is going to go in clockwise direction, negative 0.5. That's going to give me my reference angle of just 0.5299. But we cannot write our answer as negative 0.5299 because we need between 0 and 2 pi. So how can we get this exact same terminal side but positive? Well, the positive 0.5299 would be here. And that's not in the fourth quadrant. We need to add 2 pi. So I just use my calculator and I hit plus 2 pi so that it's the full decimal and not rounding anything. And it's 5.753. Makes sense for that quadrant. 5.753. Yep, because 2 pi is 6.28. So 5.753 does make sense for that quadrant. We kind of want to make sure it makes sense in the quadrant because we sometimes make silly mistakes. Now that's not the only answer. Because if it's in the fourth quadrant, that means tangent is negative. Isn't there another place that tangent is negative? Which quadrant? In quadrant 2. Remember, tangent is the ones that are like diagonal each other. So there's also an answer over here. And our theta is right here, our reference angle. But I need to find from 0 to here. I know 3.14 is pi. So it's got to be less than 3.14. We talked about this before. This is 1.57 up here. It's going to be more than that. How can I find my answer? Add pi to what? To the negative angle. So we're really taking pi and subtracting the 0.5299. But I'm going to do it on here. I'm not going to round it. I'm going to do it on here. So I'm going to do pi. And I'm going to, I'm going to add the negative, or I'm going to subtract it, so it goes less than pi. And that number is less than pi, 2.612. So I have 2 solutions. Do you remember doing this in chapter 4? It's been a while. Yeah, everything comes back in math. Everything comes back. So what we're going to do now is we still have to do inverse tangent -2 minus radical 2. We have the second part to answer. Because you are in big girl and big boy math now. I would love to show you what real life math could look like and how long it takes. But we have to have a long time for me to show you. Oh, it's cool stuff. I got a really, no, for real, I got a really cool lesson that I would love to go over sometime with you guys is like on the time. It's about the opioid overdose epidemic that's happening. We can do some math with it too. But it is very interesting and crazy and upsetting. Yeah. All right, so I did second tangent -2 minus radical 2, second tangent. And we got negative 1.286. Where is that going to be? What quadrant is negative 1.286? That will be in the fourth quadrant. It's about here. And then theta, our reference angle is just 1.286. But I need to know, starting at 0, counterclockwise, what the angle is to get there. What are we going to do? Add 2 pi. So just on my calculator, plus 2 pi. 4.997. Does that make sense for quadrant 4? Do you know what this number is down here at the bottom? Do you guys know what this number is? As a decimal? It's 4.71, so 4.99 works. Okay, but that's not the only answer. So if tangent is in fourth quadrant, it's negative. Where else is tangent negative? So we have to find that other answer, which is quadrant 2. Add pi for what? Add pi to what then? The negative. So I can go back up. And I can add pi. I get 1.856. Does that seem right for this quadrant? 1.856. What I want you to do now is get on Desmos if you have not done that. Some of you already have this equation graphed. I want you to graph the original equation, not the equal 0 part, just the expression. I want you to graph that on Desmos. Yeah, the tangent squared part, the left side. If you are using my video as notes, like the videos that we record, if you're using my video, what you would do when I say, now I want you to do this, you should pause the video and you should go on Desmos and graph it, just like you were sitting in class. You should be doing this as well. You just watch the video, you're losing part of that in-class experience. So what were we finding on this graph? What are we trying to find? Between 0 and 2 pi, the x-intercept. So we go between 0 and 2 pi, and just click on those x-intercepts like we did last week. Click on those x-intercepts. Are those the 4 answers that we just found? Did you do it on the phone? Oh, yeah, so it was the charge. Yeah. Okay, so if you are confused about what order to write numbers in, they are like decimals, it should be easy. But if you're confused, these are in order left to right. And you should be able to check your answers, and we'll do 3 decimals so that you can totally check it exactly on Desmos. Because Desmos will just give you the first 3 decimals, or round it. So we'll go ahead and write our solution. If there's more than one number, how do we write our solution? I, of course, used up all my space and have no more space, but x equals, how do I write it? Fancy bracket, and then small to greatest, yeah. So that would be, what was it, 1.856? 2.612? And then 4.997, and then 5.753. This is a big chapter, isn't it? This chapter or section, 5.3. You have a lot in this section. Now, I have a you practice, but I am pretty sure you're still going to need a teeny bit of assistance on this one. But you guys are working together. I want you to get started on the next one, and then I want you to check your answers. And when you get stuck, we will go over it. So if you're watching the video at this point, you would pause the video, and you would go and try this on your own. And then you would unpause the video to see what happens when we go on. I'm going to pause the video as myself, so it's just not a longer video. So you guys, we first needed to make it say equals 0 out of the cosecant x. Subtracting the 6. And then quadratic formulas, we do x equals opposite b plus or minus square root b squared minus 4 a c all over 2a. And then some of you may have started with x equals, but it's not really x equals. What is it? Cosecant x equals.
Oh.
So after simplifying, we get to -1 plus or minus square root of 73 all over 6. And then you say, where is my cosecant inverse button on the calculator? There isn't one. Okay. So maybe we make this into 1 over sine equals -1 plus or minus square root of 73 over 6. And then you say, where is my 1 over sine inverse button on the calculator? There isn't a 1 over sine inverse on the button on the calculator, so you can't use 1 over sine. What you have to do is you have to reciprocate both sides. So now we have sine x equals 6 over -1 plus or minus square root 73. Is there a sine inverse button on the calculator?
Yes, there is.
So that's what we're going to use. We're going to have sine inverse of 6 over -1 plus square root 73. And then we're also going to have sine inverse of 6 over -1 minus square root 73. Now, if you do not have the newer calculators, which I know some of you do not, you gotta watch your parentheses. So I'm doing this as if I have the older calculator in front of me. Oops. So if I have the older calculator in front of me, I'm going to have to tell the calculator that we're dividing this entire amount. If you have the older calculator, and you need those extra parentheses in there. If you have the newer calculator, then you could just, do the fraction button. And we get 0.91, or 0.920. 0.920. Where is that? Which quadrant is 0.920? Quadrant 1. Not here. So this is sine. Sine in everything is positive in the first quadrant. So what other quadrant is sine positive? So it's going to be Also in quadrant 2, our theta, which is 0.920, is going to be the same over here, but that's not going to be my second answer. My second answer is how do I start at 0 and get to here? You have to do pi minus that 0.920. So I'll do that on my calculator. And I get 2.222. 2.222. Yeah. Oh, you want to see what's underneath it? Oh, yeah, not a problem. Is that good? 2.222. So I got 2 answers. Have you graphed it on Desmos?
Yes.
How many answers are there? There's 4, so I'm still working on it. Of course, I haven't even typed in the second part yet. So the second part, we have to do -1 minus for 73 on the bottom. So remember, you can use second enter to get your other equation, and then just go change that to subtraction and save you some time. And now I get a negative number. I get negative 0.67, negative 0.680. So that's going to be in the 4th quadrant. Okay, so I got negative. Let me see if I can do this. That might help better. Too far. So when I type this in, I get a negative number. That's in the 4th quadrant. So sign is negative in the 4th quadrant. Where else is sign negative? 3rd quadrant. There is going to be an answer in the 3rd quadrant as well. However, this is not our answer because this is not between 0 and 2 pi. So if you add 2 pi to that answer, you will get the positive version at that same exact place. So I'm just going to take this answer and just hit plus 2 pi. We get 5.603. Does that seem reasonable for that quadrant? You ask yourself if it seems reasonable because sometimes we just make silly mistakes. If you got a number that's bigger than 6.28, you know you're wrong. So I got 5.603, that seems reasonable. Now I need to find the other one. I know the reference angle is the positive 0.680. I know the reference angle is that positive. So how do we start at 0, go around to there? What's halfway around? Hey, what's halfway around? Pi. Oh, you said 3. That's what I didn't hear. Yeah, that's pi. And then what do we need to do past pi? Add the reference angle. So on my calculator, I'm going to do pi, and I'm going to add this reference angle, except that's a negative number right now. If I add a negative number, it's going to make it smaller. So maybe I just go and just like, get rid of the negative. So I'm adding, it's getting bigger. Does 3.821 seem reasonable for the 3rd quadrant? Yikes, that was awful. Trying to write that while my body's all twisted over here. Okay, 3.821. How do we know we've done this right? Oh, because you graphed it on Desmos, and you go over and you're touching the x-intercepts from 0 to 2 pi. Do I have those right answers?
Yes.
I hope. Do you think 2 examples that you guys kind of figured out, but the teacher guided you through in class one time is enough to remember this for a test? You have to like go through this process yourself a few times. to remember it. Okay? There is one more thing, and I know we only have a few minutes before lunch, so this is just a sit back and relax. Or you can do this on Desmos as well. Like, you can do the same thing I'm going to do. We're just going to, like, lead into the other notes after lunch. What I want you to graph is just graph on your Desmos, or just look at mine. I'm graphing cosine AX, so I just put a variable in. And then I'm going to make my A value 1. Not negative. 1. There. No. Easier to do when I'm using my mouse. Okay. So I have cosine AX, and right now my A value is 1. So I have the graph of cosine X. Familiar to you? Cosine X? We've graphed it before. So cosine X. And when we're solving the equation where cosine X equals 0, we have two x-intercepts. We have two places where cosine X equals 0. But what happens, and you can see this is what we're going to, what happens when I put a number in for A other than 1? What happens if I make it 2? Watch the graph. Just watch it as I change my A value and I make my A value a bigger number. Watch what the graph does. It's cool. Watch it. Just like this. Horizontally, what's happening? I'm doing it right now, yeah. Like if I start at A equals 1, and now I'm going to A equals bigger number, bigger number, bigger number, bigger number, we have a horizontal shrink. It's shrinking horizontally, but what's happening, because this graph is periodic, we have cycles, if I shrink it, the period is getting smaller, and actually more cycles fit between 0 and 2 pi. So if I make this A equals 2, how many full cycles are there from 0 to 2 pi? There's 2 full cycles. Or if I make A equals 3, there's 3. Let's see if you're right. I could do this fast. Okay. If A equals 3, here's my first cycle. Here's my second cycle, and there's my third cycle from 0 to 2 pi. As we shrink it down, that's how many more cycles are in there.
Or whatever it is. So you just divide 2 pi by 5.
It is pretty easy, but I want to do this so I can have the mouse. Look at my first x-intercept. There's more than one x-intercept, but look at my first x-intercept when it's just regular A equals 1. If I make A equals 2, look at my first x-intercept. Right, and they're all over 4s. If I make x equals 3, look what my x-intercept does. If I make A equals 4, you want to guess what it's going to be? Let's see if you're right. Boom. What if I make x equals a half, or A equals a half? How many x-intercepts are there when I'm only doing half a cycle? There's just one, because normally there's 2. It would be half a cycle. So after lunch, we'll go over how to actually solve these algebraically. But I wanted you to see why there's more. Boing, boing. So I'll pause this till lunch. Okay, so right before lunch, we were looking at the solutions from 0 to 2 pi for cosine x. And then on your paper, it says, let's figure it out for cosine 2x. So for cosine x, there are, whoop, that's not it. Hold on. For cosine x, there are 2 solutions. This is just the parent function. There's 2 solutions. There's 2 places where cosine is 0. And then if we put a horizontal shrink factor of a half, we now have 2 cycles squeezing into 2 pi. We have 4 answers. And what did you decide about the denominator? We took that original pi over 2, and now it is pi over 4, but how? We divided by 2 or multiplied by half, okay? Which is what you do when you do transformations. When there's a 2 here and we're making like a transformation table, you would multiply all your x's by a half. Bless you. Again. So, let's look at the question on our note. So if this has a graph, we just use Desmos. You don't need to graph it. We just use Desmos to look at the graph. If you'd like to graph it to have it there, that's fine. But I'm not going to take the time to do that right now. I'm just going to talk algebraically how we're getting those answers. Just a reminder, playing on your phone right now is not going to help you retain this information. Reminder. All right, so we're trying to find y equals cosine 2x, and you guys should already know where cosine x equals 0. You should already know where cosine x equals 0. Where is cosine x equals 0? But since cosine is now, there's a horizontal shrink, like an accordion, we're squeezing it together. How many cycles fit between 0 and 2 pi now? 2 full cycles. So what I'm going to do is, this is the first cycle here. I'm now going to have a second cycle. And I'm going to tell you those x-intercepts of the second cycle, but before I shrink it in. So if I use like my unit circle and I go around, and these are the 2 places that cosine x is equal to 0, if I go a second cycle, I just go around the circle a second time. What do I add to pi over 2 to make it go all the way around the second time? We add 2 pi on. So what I'm going to do for the second cycle is I'm going to add 2 pi onto pi over 2. However, to add it when it's a fraction, we have to change this so it has a common denominator. So that would actually be 4 pi over 2. So 4 pi over 2 plus pi over 2 is 5 pi over 2. And then I'm going to do the same thing with 3 pi over 2. Same thing. We're going to add 2 pi, so it goes all the way around again. 7 pi over 2. But that is 2 full cycles. That's like if I just went from 0 to 4 pi. I still have to shrink it in. And when you look at the answers when it's shrunk in, you'll see that my numerators are the same as the ones you just wrote on the paper. It's the denominators that are different because we still have to multiply with the shrink it. We have to multiply all of our numbers by a half. So here's our shrink. There's our horizontal shrink. I'll put horizontal in there. You're going to multiply by a half. All of your answers multiply by half. So we will have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And that's what we just touched on the graph when we looked at it. Okay, when you're ready, go on, flip the page over, and we'll do another one. No, we don't have to graph it. We graphed it on Desmos instead of by hand. If I had all the time in the world, I'd have you do it by hand first. Ordered pairs? Yeah. No, we're really just solving for x. When you go and actually look at, I mean, we're talking about how they're x-intercepts, so yeah, I probably should have written that as ordered pairs. I probably should have. But when we actually solve it, it's just going to be x equals. Thanks for asking. Because you're right, I'm wrong. All right, so then we already graphed this on Desmos, so you do not need to graph it right now if you do not want to. Or if you've graphed it on Desmos, that's totally fine. You don't have to put it on your paper. I just want that visual. And what are the x-intercepts? So we already graphed it, and we looked and saw our x-intercepts when the a value is a half. We only had one x-intercept, and it was at pi. Because what we did was, since the A value is a half, that's a horizontal stretch, how much of the cycle is between 0 and 2 pi? Half of the cycle. So normally there's two x-intercepts. So normally cosine x equals 0. The x would be at pi over 2, 3 pi over 2. But since it's just half a cycle, I'm only going to use pi over 2. I'm not going to use that 3 pi over 2. Well, my answer was not at pi over 2, was it? So we use half the cycle, and then what we do is we stretch it. We stretch it so it goes from 0 to 2 pi. And because we stretched it, that's the same thing as like taking this answer and multiplying it by 2. So we multiply by the reciprocal of that half. So x is just pi for that one. And that's what we had on our graph. Okay, so now we're going to try it without the graph, but you have your Desmos in front of you, so you can check your answers as well, but I'm going to work through one without the graph. So the first thing I'm going to do is I'm going to look and just ignore the 3. Totally ignore it. I'm going to say, do I know the answer of just cosine x equals a half? Without the 3, without that horizontal stretch or shrink. I should. What? Pi over 3 is one of them. Where is cosine positive? First quadrant and fourth quadrant. Pi over 3 is the first answer. What's the second? So pi over 3 and 5 pi over 3. So that's just one cycle of cosine where it equals 1/2. How many cycles will we go through when we shrink this by a third? We'll go through 3 full cycles. So what we're going to do, and remember to get the next cycle, we're going to add 2 pi. So we're going to have a second cycle, and we'll have a third cycle. And just for anybody out there that's like, I don't know why she knows that there's 3 cycles. How do I know that there's 3 cycles? Nevaeh? That 3 in front of the x is telling me how many cycles there will be to shrink in and fit.
So the second one, does that mean there's 2?
There will be 2 cycles. Yep, you got it. All right, so now to add 2 pi, I need a common denominator, so 6 pi over 3. So we'll have 7 pi over 3. We'll have 11 pi over 3. And then to get the third cycle, what am I going to add? Another 2 pi. So we'll have 13 pi over 3 and 17 pi over 3. But that's not the answer. That's just 3 normal size cycles. Now we have to shrink it in. So all three of those cycles fit between 0 and 2 pi. So to shrink that, we're going to multiply by our horizontal shrink factor, which is 1/3 of x equals pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9. Did you say yikes?
Yeah.
Oh, you wait till there's more. I'll just type it in just to confirm, because this is what you guys should be doing, just to make sure that your answers are right while you're still just learning. What was it? Cosine 3x equals a half? Nope. Minus a half? There you go. Pi over 9. 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, 17 pi over 9. Yay! Let's try another one. So sine 2x minus 1 equals 0. We're finding the x-intercepts, but we can do that by moving the 1 over. And then think, for cycle, we're just thinking like sine x equals 1 without the 2. I'm just thinking like sine x equals 1 for our first cycle. where is sine x equal to 1? Pi over 2 only. If you need to draw it, if you don't have those memorized. So how many cycles will we have? Somewhere right here tells us 2 cycles, so we'll have a second cycle. So I'm going to add 2 pi, which is the same thing as adding 4 pi over 2. And we will get 5 pi over 2. So that's 2 full cycles. But what do I have to do to those 2 full cycles? I need to shrink them. Multiply by 1/2. Perfect. So we'll take those answers, we'll multiply by 1/2, then we'll get pi over 4, 5 pi over 4. How do we know we did it right? Get on Desmos and get touch those x-intercepts and make sure that it's right. I did not. If there is a number in front of the x, you will have a shrink or a stretch. On this one, we had a stretch because we ended up multiplying by 2. Yeah. If it's whole number, when you flip it, it's going to shrink because there's going to be 3 cycles in there, so they're going to be closer together.
And that's only if there's something so like
In front of the x.
Okay.
And we've done horizontal shrinks before when you graphed it and you put it in your table, multiply by 1/2 or whatever. We've done them. We're just solving for x now. We're finding those angles. All right. How about the next one? What's the first thing you kind of want to think about? Cosine x equals 1/2. Oh, good. We already did that one. I said we already did that one. Yeah, we've done that one for like how many weeks now? A lot. Okay. A lot. So we have where cosine x equals 1/2, but it's not cosine x. We have some cycles. How many cycles should we be using? 1/2 of a cycle. So here's the whole cycle. What part should I use? Just the first part. Just the first part. The first half of the cycle. Higher grade. After you use that part of the cycle, that's still not the answer. You still have to use the stretch or shrink, which since it's 1/2, we're going to multiply by what? Yeah, multiply by 2. So the answer should be 2 pi over 3. Should be.
So, when it says half cycle, you're only going to use the first.
You will always use the first. Because starting at 0, it'll stretch it away from the y. So when we go from 0 to 2 pi, it's always just going to be that first.
And the second one turns into 10 pi over 3.
Yeah. What is going to be 10 pi over 3? Right, and that would be past that 2 pi. If we multiply that one by 2, it won't be between 0 and 2 pi. Okay. All right, so this last one has a tiny little extra thing added to it. What do you think I should think of first? So if you do square root, what's my next one? Oh yes, that's a 30-degree reference angle, which is pi over. I don't need these yet. So my first cycle is going to be all 4 pi over 6's. Pi over 6, 7 pi over 6. Nope, skipped one. 5 pi over 6. 7 pi over 6. And then 11 pi over 6. That's the first cycle. So Paul, how many cycles? How many cycles? How many cycles will I have? Yeah. So here's my first cycle. I need a second cycle and a third cycle. What will be adding each time to get to the next cycle? we add when we had multiple cycles
Oh,
before?
2 pi.
2 pi. Now I can't add 2 pi. I have to disguise it. So it has a, yeah, I have to disguise it so it has a common denominator. So 12 pi over 6. So now we're just at 13 pi over 6. 17 pi over 6. It's not too much. It's just much. It's not too much. 3 pi over 6. We're going to add another 12 pi over 6. 12 pi over 6. Guys, not all of them are going to have this many answers, I promise. It's a total of 10 questions. Total. But that's between both different things that we did today, quadratic formula and this. Total of 10. Okay. So now, is this my final answer?
No, it's probably.
Well, you know what? Yes, but I like to think of multiplication instead. So I'm going to multiply by 1/3. Or you could divide by 3. That's the exact same thing because we're putting a shrink on you.
And you only do that to the third cycle.
No, you do to all the answers.
So there's it.
So we have 12 total answers. Would it make you happier if you just erased all the 6s? Instead of rewriting it all? You just like erased?
Yeah.
Okay, then do that. I'll just rewrite them, but you can erase. So I have pi over 18. I have pi over 18. 7 pi over 18. Is this math challenging?
No.
No, it's just something that's serious. I know. How could we make it less? Don't tell me not do it. Can you tell me how we can make it less work for ourselves without not doing it? Well, I mean, yeah, so unfortunately you have to be able to do this without the aid of just a computer doing it for you. But if there's a way that we could, you know, if I could save you some time of writing, I'm all about that. So if you'd like to not write all of that twice, if you'd like to, you know, change all your 6s to 18s, I'm okay with that. I understand, but also I didn't give you 10 questions that have that many answers. And we're done with our notes. So the assignment is a worksheet which I'm going to hand out, and then we will grade it on Friday.